Hello, we are going to learn today how to do Newman projections. So Newman projections. And so what's that? What is a projection anyway? So let's say I'm going to show you the subject and you see what it is from this perspective. However, if I show it to you this way, you wouldn't know what it is, or this way. So there's several ways of viewing this. And say that we have this gator, right? So you can see clearly it's a gator from this perspective. Now you have another perspective, yet it's the same object or this perspective. So this we're going to do with molecules. Now I have this molecule, I'm holding it by my hand. And notice there are several ways that I can do snapshots of this different ways. And I can even do something like this. Say that one of the two carbons is actually eclipsing the other carbon. So that's another way of picturing. I have this molecule that has two chiral centers. And we can, if I take, say, my snapshot like that, it looks different. You don't see all the bonds, right? Well, this is exactly what a Newman projection is. We're going to be viewing molecules this way. So I'm going to start drawing a molecule showing you wedges and dashes, which is our normal way to represent 3D. So now I'm going to say that I have here a bromine, chloro, and then I am going to say that I have a metal here, and I'm going to show all the atoms just because we're doing Newman. I want to make clear here. And now I'm going to draw another metal and another hydrogen. Now I have here clearly two chiral centers, two carbons with 4 different substituents. Now we're going to view like we did before. We had this view, and I'm going to view it in the front. Or say here we have this view, and now we're going to view it this way. Now for the molecule that you have here, you have, is not, the first one I showed you was this. So those two substituents are eclipsing, but the one that is actually in the picture is different. It is like that. So now let's, I'm going to draw my eye where my, say, perspective is. And here's where my eye is, right? So I'm going to be looking at the molecule from this side. Let me use another color that's actually not so bright. Let's look at that from that perspective. Yep. So if my eye, if I'm looking through this bond, right? First I see this carbon, and then the other carbon is right behind. So what I'm going to draw is what I see first. So let's draw one circle representing this carbon. Now from this point of view, and let's say that we stand this way, I see a chlorine going down. See, I am here. I see this chlorine going down. And standing here on the side, you see that there is a metal to your right. And going inwards, there is a hydrogen. So think about now, I'm going to make a rotation of this. I'm going to give you a sawhorse projection. In doing the sawhorse, this is what you see. So I'm tilting this slightly. Let me erase that and show it another color. This is not showing very well. Apologize for that. So let's do that in a different color. Like I said, I'm going to tilt that a little bit. And we're going to say this is the chlorine. And now here I have a metal group. And on the other side, I have a hydrogen. Same, now rotating that. Now the carbon in the back has a bromine up. And I have to see if I am positioned here, it is to my right, the metal. So now I'm going to have metal, and I'm going to have a hydrogen. if I keep moving this, so from say tilted to completely like that, I have the Newman. And now I see here, again, chlorine is down. I see to your right, you see a metal group, which was here on the wedge. So here's my view, metal on the right side. So I'm going to draw metal here, and then the hydrogen. Now, I don't see from this perspective, I am not able to see the carbon, that one there. But I see what's connected to it, and I see that there is a bromine up. So I'm going to draw that one. And then I see, again, you're standing in the same place. This is your view. The metal is to your right, and here it is also in the sawhorse projection. And that's your wedge dash, right? In 3D. Now, doing that, the carbon in the back is going to have the metal to your right. The metal is here, hydrogen is here. And that is your Newman projection. Okay, so, and it's very important to see that. Let's try to name the compound. And then we're going to figure this out here in the other drawing. We have here, remember your IUPAC rules. So I have 1, 2, 3, 4 carbons, atoms. So it's some butane. I'm going to write here, butane. And then I'm going to number the chain. I see substituents are bromine and chlorine. So I'm going to say carbon 1, 2, 3, and 4. So this compound is 2 bromo, 3 chloro, listing alphabetically, 3 chlorobutane. And what I want you to see is that you can do that also in the Newman projection. You're seeing the molecule now through the bond that is between carbon 3 and 2. So that's your carbon 3, right? And carbon 2 is in the back. Notice that this metal attached here is, this one is carbon 1. Carbon 2, you don't see, it's right behind 3. So 3 is here at the front where your view is, and then you have carbon 4. So you said your 4 carbons, butane, and you know that in carbon 2, which is right behind, you have a bromo, and in carbon 3, you have a chlorine. And I do this because there will be instances, there might be questions asking you names of compounds that may be drawn this way and not the other way. So it would be important if you can recognize that. So let's try to do more exercises about Newman projections in other videos.